open. Everybody should have open tab on practice set 8.4. All right, so first, does anybody have a question? I am going to do problems 3 and 5. Does anybody have a question on 1 or 2? No? Okay. If you do, you can always ask at the end. Okay, so looking at number 3, it tells us that now you all should see, you all have a different presentation than what you see on the screen because it was too much for me to create the table twice. Sorry. So what you have here is the resulting table. But your table, or this will be the answer to the first one. So it asks you, wait a minute, I'm going where you are. All right, so the question says, the table shows information from a survey about the resting heart rate in beats per minute, BPM, for 50 people living at altitudes above and below 10,000 feet. So you should see on your screen, because again, you should have that tab open to the exercise set. You should see if we are going, the columns are below 80 BPMs, above 80 BPMs, and then the total. The rows are above 10,000 feet or below, and the total. So you see there are, so now first, when you look at this table, what does 3 represent? Again, this is about interpreting the data that you see. So that 3 in that second row, second column, what does that 3 represent? Don't all speak at once. And you know, now that I see my screen, I'm going to need you to talk. I can't see what you're typing. I'm going to give you some time to think. I'm going to go get me some more coffee. So what happened? Or any number. What does 16 represent? What does 19 represent? What does 19 in the second row, third column mean versus the 19 in the third row, second column? What do they
Above and below.
All right, above, right. So above and below. So the 3 represents the people whose heart rate is below 80 beats per minute, but they live above 10,000 feet. Absolutely. Thank you. All right, so again, in looking at your graph, so that means 16 people have a heart rate below 80 beats per minute, but they live at 10,000 feet or below. So that means that 19 people live below, or excuse me, have a heart rate below 80 beats per minute. 31 people have a heart rate above 80 beats per minute. 22 people live above 10,000 feet. And 28 people live 10,000 feet or below. All right, so now let's look at what the problem is asking you. It says create a two-way table that shows the relative frequencies for each of the values. So the relative frequencies are just the decimal equivalent of the probability. So remember, how many people did they say? How many people did they use in this survey? That's bad. Don't all speak at once. How many total people are there that took the survey? I'm gonna give y'all a chance to wake up. I'm gonna go get some sugar for my coffee. I'll be back. Oh, Millie, pick it up. All right, somebody talk to me. How many people took the survey?
$50.
Thank you. I love you. All right, so now that means in each of these blocks, we are going to divide whatever we were given by 50. So in the box that coincides with a heart rate below 80 beats per minute, but they live above 10 feet, it's 3 people, but it's 3 of the 50 people. So your answer, again, like I said, is just the decimal equivalent of the probability. Okay, so again, 3 out of the 50 people surveyed have heartbeats below 80 beats per minute, but they live above 10,000 feet. All right, so we're moving over. Same thought processes. So the people whose heart rate is above 80 beats per minute, but they too live above 10,000 feet. Well, they told us there were 19 of them. So again, 19 out of the 50 people. So that's like 38%. Yes, that's better. All right, in that last column. Now, if from the original chart, 3 plus 19 gave you 22, what then could you assume would be the percentage when we talk about the total people who live above 10,000 feet? Because again, our original chart said there were 3 people here, 19 people here, giving us 22 people here. So if this is 6% and this is 38%, what would make sense that this percentage would be? %6 and 38% will give you 44%. Okay, so with that said, so for the people whose heart rate is below 80 beats per minute, but they live at 10,000 feet or below, somebody help me out. What does the probability look like? Remember, the probability is going to look like a fraction. How many people out of how many people were surveyed? Somebody talk to me.
16 out of 50.
Loving you, absolutely. 16 out of 50. So that's about 32%. Again, this operates in the same way. So anytime they ask you for the relative frequency, remember, all they're asking you is, what is the decimal equivalent to the probability? So this means 32% of the time, you will have a person whose heart rate is below 80 beats per minute and they live 10,000 feet or below. They live at altitudes of 10,000 feet or below. All right, so the next one, same way. Somebody tell me, what's it look like? What's the probability look like?
12 out of 50.
Loving you. Yep. 12 out of 50, that's about 24%. So again, 24% of the people surveyed have a heart rate above 80 beats per minute, and they live at 10,000 feet of altitude or below. And lastly, again, if we use common sense, if this is 32%, this is 24%, it will follow that this will be how many percent?
56.
Loving you. Yep. So if we look across this way, this means that 56% of the people surveyed live at 10,000 feet or below. So now we're in the last column. So again, if common sense serves us, if we are just looking at the people whose heart rate is below 80 beats per minute, if there was 6% who lived above 10,000 feet, there were 32% that lived below. So it would make sense that this total should be how many percent?
38.
All that. Yep. So, here's my thing. Yep. So 19 of the 50 people surveyed have a heart rate below 80 beats per minute, and that's about 38% of the people. The next column, 31 people out of the 50 surveyed have a heart rate above 80 beats per minute, and that's about 62%. So when we add these two together, what you get? Because now we're talking about all the people. Bam.
100.
Absolutely. So going across, 38% plus 62% will give us 100%, which is 1. And coming this way, 44% plus 56% will also give us 1. So this is what they expected in that table. Again, like I said, you are merely going from the probability to its decimal equivalent. And you know decimals and percents, they go hand in hand. All right, so, excuse me. So there are 50 people in total, and the numerator is the number of people in that situation. Okay, so I'm going to give you a chance to fill that in, and then we're going to go to the next 2 questions. Because again, number 3 had 3 parts. So the chart was the first part. The creating the relative frequencies. And now that you have the chart, while some are copying, some of you have already done this, see if you can do B and C so that we can have some conversation. Oh, damn, it's 11 o'clock already. All right, everybody good with this portion? Okay, your silence means it's fine to move
Not
on.
yet. Not
Oh,
yet.
okay. Thank you. Okay.
All right, I'm finished.
Okay. Moving on to the next one. All right. So I just copied the table over, but this time I just left in the relative frequencies. Okay, but it's the same table. So now the B portion or the second portion. What is the probability that a person surveyed, selected at random, has a heart rate above 80 beats per minute or lives above 10,000 feet. Excuse me. Alhamdulillah. Excuse me. Okay, so again, what is the probability that a person surveyed, selected at random, has a heart rate above 80 beats per minute or lives above 10,000 feet? What do you propose? Where would you get those values? So now, remember, this is an or. So you have to look at both situations. So where would we get this number? The number of people surveyed who have a heart rate above 80 beats per minute. Where would we get that number? We're looking for people in the survey who have a heart rate of 80 beats per minute. Again, we're in our graph. We're at. Where would we find this value? Or will we find this value? The number of people or the percentage of people who live above 10,000 feet.
$22.
22. Why 22? Well, first, go. Oh. Listen, I want you to look at. Can you see my screen? Come back to my screen.
Yeah, I can see it.
Okay. So, I want to know this. What's the total number of people who have a heart rate above 80 beats per minute? The total now.
31.
We don't have 31 on our chart, my love.
I see it.
Oh, I see. What's the relative frequency? Okay, so yes, where 31 would sit, absolutely, yes. So yes, so you would use 0.62. Absolutely. So that is all the people who have a heart rate above 80 because it's 31 out of the 50. So then where would we get this part? People that live above 10,000 feet. So now hold on to this 0.62. Where would we get the other piece? Because now we did
44.
Just the people that live above. Because remember, when we came, this 62 takes into consideration this 38 because these two together total to 62. So we can't count this 38 again. So what portion can we count? That live above 10,000. Stay with that same train of thought. This 38% is counted in this 62%. So we can't count it twice. So what portion are we missing?
The 0.6.
All day, yes. So for the first one, you have the 0.6 because this little piece, these people still live above 10,000 feet. And again, you were on the right train of thought. Yes, we are using this row, but this 38%, we already counted in the 62%, so we can't count it twice. So this is all of the people whose heart rate is above 80 beats per minute. And then this is the piece of the people who live above 10,000 feet, because these people have both. So he already counted those here. So these are people who live above 10,000 feet. And these are all the people whose heart rate is above 80 beats per minute. So together, it's about 68% of the people. So 68% either have a heart rate above 80 beats per minute, or they live above 10,000 feet. Okay, so it's either or. They are either in this group or this group. Make sense?
Yeah.
Okay, I was going to say, does it not make sense to anybody? We needed the two pieces. Okay, but now, when we look at the C question, C changes up the game. What is the probability that a person surveyed, selected at random, has a heart rate above 80 beats per minute and lives above 10,000 feet? So now it has to be both things. The first one, it was one or the other. Here, I need both. So we're using the current, relative frequencies. How many people fit that description? Where do the two situations meet? Again, the person's heart rate is above 80 beats per minute. So find that column. And they live above 10,000 feet. Find that row. Just like if you're plotting a point, where do those two events meet? At which number?
38.
All day. All right, so see, the difference here is you have to, the difference between B and C, or the second portion of the problem and the third portion, is here it's or. So you have to look at both situations. But here it's and. So you go to, where do they meet? So we come across here above 10,000 feet. We come down here above 80 beats per minute. This is where they meet. Just like plotting a point. Okay? So here is the meeting point. So here, because it is an and, you don't have an add. Okay, it is what it is. They meet right here. That's the answer. So type that one in for number 3. Now, what I see in number 4, do you all see a spinner on your copy of 8.4? Because I don't see one. It may not have transferred.
No.
Okay. All right. So 4, of course, you can't do. And that was a publisher issue. That wasn't our issue. All right. So I'm going to give you a couple more minutes to get this down. Maybe about 1.5. And then we're going to move on to number 5. And number 5 is merely asking you, how would you find the sample space? So that means there is no one right or wrong answer. It's just how would you find the sample space? Okay, we've been working on sample spaces, so all right, we good with 3? All right, so in number 5, again, you could have listed the sample space any way you wanted. So what I introduced on the screen is like a tree diagram. And we say tree because these lines serve as our branches, of course. So this is the event. This is one event. The event is flipping a coin. So if you flip a coin, you can either get heads or tails. So that takes care of the coins. But now the spinner they gave you had 4 letters. So when we get heads, we can either get heads and a W. We can get heads and an X. We can get heads and a Y. And we can get heads and Z. So this is one way that you could find the sample space. Now, some of you may have chose to make a list, and that's normally what we do. So you would have, if you made a list, you would have matched them up. You would have had HW, HX, HY, HZ, meaning every time you flip that coin, you got a heads. But every time you hit the spinner, you came out with a different letter. Okay? So, of course, in here, you would have the outcome heads and X. Here, you would have the outcome heads and Y. I just did the first one and the last one. So, if we come off the other branch, when we flip the coin, and we come up with tails, well, this time tails consistently comes out. So we get tails from the coin, but then from the spinner, we could get a W, we can get an X, we can get a Y, and we can get a Z. So again, I didn't include on the tails end, I didn't include the first one or the last one. So again, you have 3 ways that you can list a sample space. You can do it in a list. That's what we've been doing. So like I said, heads W, heads X, heads Y, heads Z, tails W, tails X, tails Y, tails Z. That's one way you could find a sample space. You can use a table if you like. Okay, and so this is the third way. The third way is a tree. So everybody has their own way, whichever way you think is easiest for you to make sense of what they're asking you. Again, This is the result of the first portion of the experiment, the flipping of the coin. You can get a heads or a tails. This is the second event. What can happen from the second event? Make sense? So again, for number 5, you can list the sample space in whichever way is most comfortable for you. If you don't want to write out the sample space, you could just describe to me how you would find the sample space. So don't feel committed to making a chart. You could tell me in words, but remember, your words should be in complete sentences. Okay? I would find the sample space by, or the sample space can be found by, and then explain to me what you're doing. Remember, part of Summit is to help you think about your answers and what they represent. Like, they're not just numbers, okay? They are the result of something. They mean something, okay? So from this sample space, a whole lot of questions can be derived about probability. What is the probability of heads and X? What is the probability of heads and not X? Okay, so a lot of questions can come from a probability problem where they are asking you to find the sample space. And remember, for those of you who haven't been here in a little while, the sample space is merely the list of outcomes. What can happen from these events? So the sample space, again, is the entire list. So it's 2 more in here, and there's 2 more in here. Okay? Questions, comments, concerns? Again, you describe to me how you would find the sample space if you don't want to draw one or list one. All right, and looking over this practice set, any other questions, comments, or concerns? Remember, in number 6, take into consideration that you must reduce. All right. I have a question. Are any of you feeling overwhelmed? We won't know who you are if you respond. Okay. All right. I'm just asking.
I just shit.
You just
Yeah.
you just quiet.
Tired as shit.
Well,
Lisa, I'm gonna get the work done in my own time, though.
Absolutely. All right. So your first progress report is coming out on Wednesday.
How we get it?
You are probably going to get it electronically.
Oh, in the mail. I mean, I sent a mail and email.
Yeah, in the email. Yep, exactly. So again, those of you who may not have been keeping up, please just do the assignments. Okay, just do the assignments as soon as you can. Please use the office hours if you need to. You don't necessarily have to talk to me face to face. You can send me a text. And if you send me a text, I will do my best to explain to you in words what the problem is asking. But if that doesn't help, remember, you can always call me through Google Hangouts. Go to Google Hangouts. If you type in my name, I do believe it will call me for you. Okay? Because you might not have a question now, but as you go through the problem sets, you may come up with a question. Okay? Again, Let me see. Some of you, Miss Richardson, this housekeeping things now. Miss Richardson is trying to reach some of you to get a survey done. Please respond to her. All right. So, everybody good with 5? No questions, comments, concerns. All right. So, you know that means we what? Moving on. All right. So, this next unit is called combining events. And in a nutshell, we are going to look at events that happen within other events. Okay? And an example of that is, again, a game of chance, cards. Well, if you are playing blackjack and there are 3 of you, you know that there are 52 cards in the deck. And there are 13 cards in each suit. And that means that there are 4 of each card in the deck. So there are 4 aces, 4 kings, 4 queens, 4 jacks. So you know that once the 3 cards are played, there are no longer 52 choices. Okay? Because you just took 3 of them away. So now for people who count cards, those of you who have seen the movie 21, so now you know the odds of you getting 21 have just changed. Because initially, if you the first person, now it's 51 cards. They give out the next one. Now it's 50 cards. They give out the next one. It's 49 cards. Now, you have 49 cards. You have no idea what the other people's cards are. So again, one event, the dealing of the first card, has a direct relationship on what happens for the rest of the game. Okay? Because if 2 people get aces, and 1 person gets a king, so now that means there are only 2 aces out there. So that person with that king who trying to get 21 straight up, their job just got a little harder. Okay, because there are only 2 aces left versus the 2 people who got the aces and they looking for any face card. So that means they have the 4 jacks still hanging out there. They have the 4 queens still hanging out there. And they have 2 aces. So they have 7 cards that could possibly make them a winner versus the person sitting with the king. Make sense? How one event relates to what happens in the next event. All right, I'm going to try to make it a little plainer. So the warm-up is called Notice and Wonder. Oy. So, sorry. Notice and wonder. Oh, come on. Oh, me and the machine, All right. Once again, we are using our cyclical math talents. Something that you have seen before is coming back. All right, can everybody see? Activity 1, notice and wonder. Birds and bats. So again, remember, notice and wonder just gets us thinking before we move into the concept. So now, general question. What do you notice? What do you wonder? First of all, does anybody remember this construct? What's this called with the 2 overlapping circles? What are they called? Well, what is it called? Ooh. Will it help if I tell you it's 2 words? Will it help if it tell you that the letters are VD? No, nothing. Oh, come on. All right. Because our time is moving on. Okay, so got a question. What? All right, the blue words. Can you see that this word is blue and this word is blue? I'm going to take that as a yes. All right, so what are the blue words?
I can't see that slide.
Oh, okay. You on my screen?
Yeah, I'm talking about for my computer though.
Okay, wait a minute. I'm going to see. Did that help?
No, I'm saying like I don't see that on my computer. Like,
All right, you back with the class? Can the rest of the class see it?
I can see it on the screen that I'm watching. I'm talking about like the slide and stuff, like how to get to it.
Oh, we can't. This again, if we were in school, this would be something I would have to give you on paper. Oh. So we just have to you just have to respond from what's on the screen. All right. So again, blue words. What are they?
Birds and bats.
All right. So now, what does this circle tell you about birds?
Feathers and lay eggs.
And what else? They have feathers, they lay eggs. What else? It's this whole circle.
Wings and eat insects.
That's right. They have wings and they eat insects. So what about this circle over here? The circle on the right. What does it tell you about bats?
Teeth, sleep upside down, wings, and eat insects.
Exactly. So common sense tells you what these 2 characteristics are what? Or these 2 characteristics belong where? Or belong with whom?
Both.
Exactly. So remember, first of all, does anybody remember what the construct is called? When you have 2 overlapping circles, like I said, the initials are VD. Okay. All right. So remember, this is called a Venn diagram. And a Venn diagram is usually 2 or 3 groups, because after that, it gets a little confusing. But it's 2 or 3 groups, and they're making a comparison. So again, everything within this circle on our left relates to birds. They have feathers, they lay eggs, they have wings, and they eat insects. The things on the right side relate to bats. They have teeth, they sleep upside down, they have wings, and they eat insects. But in the overlap, the intersection, these are the things that they both have in common. So both birds and bats have wings and eat insects. Now, what you think this out here means? Because it's in the diagram, but it's outside. So what does it mean about this? Well, what do you think this means?
Something they both don't have.
Exactly. This thing does not relate to either group. Okay? So again, Venn diagram, it tells the two groups. It tells the characteristics of the groups. It tells you what they have in common. And it tells you what does not apply. And all of that information came from 2 circles and 7 characteristics. And you got all of that information. Okay? So that's where we're going with this. Again, remember, we are going to model information in several ways. All right. So let's go back to our presentation here. All right. So again, our topic is combining events. So Venn diagrams are multiple overlapping curves. So they are usually circles. Each circle represents a set. So sometimes the set will be an animal, like we just saw, bats and birds. But for math, a lot of times you will see it's going to be numbers. Okay. So most of our examples, well, some of my examples and some of my groups, what we're going to look at. So the members. So that means a set can have one. A set can have one element. Okay. So the members or the elements in both sets go in the intersection. And again, I'm going to show you. So just follow me for a minute. So sets contain elements. So if set C is equal to, now this is called set notation. You have the little brackets here. The elements of the set go in between, separated by commas, and then you close it with the brackets. So here, set C has 3 elements, and those elements are the numbers 3, 5, and 7. Okay? And again, this will be on the video, so you don't necessarily have to write it, but you should be familiar. Okay, so there are 2 sets, set A and set B. And again, their intersection is a member of both sets. So for us, if set A was John, Joan, and Jean, set B will be Rita, Jean, and Troy. But because Jean is in both, Jean will sit here by herself. John and Joan will be here. And Rita and Troy will be here. Make sense? Again, the individual sets, but their intersection, whatever or whoever is a member of both sets, goes in the middle. Okay, so we don't count her in set A individually and then set B individually. Because she sits here, we understand that she is a member of both sets. Make sense? Okay. All right, now we have operations that we do with sets. And one of those operations is called a union. And a union is self-explanatory. When we unite something, we put them together. So a union is combining the elements of 2 or more sets. This symbol, it looks like a U. Okay? So, and as a notation, it will have a set, the union symbol, and then the set that it will be uniting with or combining with. And if it were in words, it's A and B. So here's the example. If set A is this set of numbers, 1, 4, 5, 9, and 13, and set B is this set of numbers, 2, 5, 6, 8, 9. A union B, A uniting with B is equal to, then we list the elements in each set, but we do not repeat. So there is a 5 here, there is a 5 here. In our union, the 5 is only represented one time. Okay? The same for the 9. There is a 9 in set A. There is a 9 in set B. But in the set that is the result of the union, the bringing, the combining them together, you only list each number or each element one time. Does that make sense? Okay, so don't get this concept mixed up with when you're finding the mean, mode, and the median. You know, measures of central tendency, because there you list each element. No. Here, each element is only mentioned once, even if it is in both sets. Make sense? Okay. We also have an intersection. And an intersection is just that. It is where the two sets meet or cross. And the intersection is the elements that are in both sets. And the symbol is upside down. So it's like you are trapping those things that are in both sets. And the notation would look like this. The first set, the symbol for intersection, we are holding down the members of the two sets that are the same. So again, A or B. So it can be in this one or in that one. Okay? Again, has to be in both. So for again, staying with the same set, 1, 4, 5, 9, 13 or sets. And set B, 2, 5, 6, 8, 9. A intersection B. These two are in A. The same two are in B. So the set created by their intersection has these two elements. So for the intersection, the elements must be in both sets or all sets. Make sense? Kind of, sort of. Okay. Last one. When we talk about sets, there is also something called a complement. Now, a complement is a little different because it introduces something else. It introduces the concept of the universal set. And a universal set is whatever they tell you it is. So sometimes they will tell you that the universal set is the numbers from 1 to 9. Then in another problem, it may tell you the universal set are the integers from -10 to +10. Okay, so the universal set is defined by each problem. There is nothing that is, every time you see universal set, there is not a group of numbers or a set of numbers that comes to mind. The universal set is whatever they tell you it is for that particular problem that you are working on. Okay, so the symbol for the complement is this little red, is this little symbol. Okay, so the notation, you would have the name of the set, and then this little mark here, it's an apostrophe, means not. So not A. So when you have a complement, you are comparing the set they are talking about to the universal set that you were given. So for us, The universal set we are calling U, and it is the numbers from 1 to 13. Okay? So, our set A are the 1, 4, 5, 9, and 13. So, to find the complement, you are comparing set A to the universal set, and this is asking you, what is in the universal set that is not in set A? So set A only has these 5, whereas the universal set has all of these. So everything that is in the universal set that is not in A. So 2, 3, 6, 7, 8, 10, 11, and 12. Let me move that out the way. Okay, so these numbers are not in set A. They are elements of set U, which is the universal set, the set we're comparing, but they are not in our set. Okay, so again, complements means what is in the universal set that is not in our particular set. Yes, no, maybe, could be, possibly. Well, I set up an example, so let's see if we can do this. I'm going to need your responses. All right, so the universal set is S, and it is the numbers 1 through 6. And we have 3 sets. So our set A is just the 2 elements, numbers 1 and 2. Our set B are the 3 elements, 2, 4, and 5. And our set C are the elements 1, 5, and 6. So now, our first problem, set A united with set B. So we are putting the 2 sets together to create a new set. And remember, if they have elements in common, we still only list it once. So what is the resulting set if we unite set A and set B? You're going to have to talk because I can't see if you're typing. While you all are thinking, I want to make sure I have everybody. All right, so I have Mr. Gambrell, Mr. Harper, Mr. Jenkins, Miss McNeil, Mr. Stewart, Mr. Wilkerson, and Miss Wilson. Am I missing somebody? Okay. 1, 2, 3, 4, 5, 6, 7. I have 7.
The shorty having her hair.
Oh, hey, have. Okay, thank you. Is in here. Thank you. Good looking out, my love. All right, so again, we are uniting. So we have these 2 elements will be uniting with these 3. We do see that we have an element in common, but we will still only write that element once. So when we unite the 2 sets, we end up with the new set of elements 1, 2, 4, and 5. So for number 2, we are uniting the set B with the set C. Again, we will only write each element one time, even if it is in both sets. So the resulting set, what you got? Somebody?
1, 2, 4, 5, 6.
1, 2, 4, 5, 6. Absolutely. So again, remember, a union, you just put them together. And again, each element is only listed one time, even if it is in both sets. All right, so looking at 3. Now we've turned that union upside down. Remember, that now is the intersection. We're going to trap what is in both sets. So if we take the set A intersection with set C, what is in both?
1.
Absolutely. A set can have one element. So the set created by the intersection of sets A and C is only one element, and it is the number 1. For number 4, what is the intersection between groups B and C?
5.
Yep. Bam. Still only one element. Now, C is asking us, what is not? That is the complement of C. So what is in the universal set that is not in set C? What is in the universal set S that is not in C?
2, 3, 4.
Bam. All right, makes sense?
Yeah.
Okay, cool. So remember, only when you are doing the complement, only when you are doing problems like number 5, will the universal set even matter. Okay? Otherwise, you deal with what they give you. All right, so that's the end of the presentation. So now, next Monday, your assignments is the cool down from this section and the exercise set. Again, if you get in a spot, make some contact. I think I'm going to do one of the activities from this set next week, just to make sure that you all have it before we move on, because we are in week 4, but we only have 8. So you only have 4 more meetings. You have 3 more meetings, and then the 4th meeting is going to be your final. Okay, and again, because I am not there with you to take your final, I am going to have to see you, and it's timed. Okay, so everybody had assignments? So I'm going to do my best to make sure that you all have everything that will help you pass the class.